Yes, hello. So I hope the microphone is good. So yeah, my name is Victor Botev, and I'm also from Iris.ai. Yeah, together with Anita, who spoke earlier, we are working on a slightly different angle for large language models. I first want to thank Associate Professor Kutuzu for the great presentation, because I'll be touching upon some of those concepts, but I don't have that much time, so it's good that you already have the foundation for that. But basically, one of the things that I want to say before I start is that here we're going to talk about plausible texts and factually correct texts. And for us, since we're building these tools for helping researchers, factually correct texts and factually correct information is really important. So I would start first with, yeah, what is the current focus of language models? Like we had this discussion about predicting the next word and so forth. So basically, the current goal of language models is to give you plausible, coherent text that actually it's abstractive. It's paraphrasing what someone else is saying. It's abstracting on top of the information, generalizing, and so forth. But they're not particularly good at focusing on concrete facts. So if you want to focus on, let's say, an exception of the rule, or if you want to focus on a concrete date or a phone number or an email, it hallucinates a lot. It can give you wrong answers. So paraphrasing is great, but as I said, like, numbers are problematic. Sometimes if you paraphrase a number, it actually creates a wrong fact. Most probable words are also great, but not for very endemic words. Like, for example, here I have a conversation with the ChatGPT about a particular material and I asked, is it a good conductor of heat? And it answered yes, because most of the metals are actually good conductors of heat, except that this material is actually an exception. And because it's very underrepresented in the literature, since these properties were very recently found, I believe that was why it got it wrong. But anyway, so also, like, there are some irregular tokens, like I already mentioned, like numbers. There are some other entities like chemical formulas or other stuff in science that actually don't match exactly the same logic. So, or you need vast amount of data for training, or you need to do additional reinforcement or fine-tuning for every particular domain. We do that to some extent in our own models, but our models are much cheaper to operate, so it doesn't cost you a fortune to actually retrain for every specific niche or every specific new discovery that people do. So yeah, well, what are the factual correctness issues that we have discovered with some of those large language models, and why we're not particularly using them out of the box? We have to build something on top, and I'll discuss our pipeline of what we are building on top in order to actually mitigate some of those issues. Obviously, one of the things is hallucination. We already discussed it quite a bit in this hall here. We saw it in the previous slide, and there were other such hallucinations. The other thing is also like mixed context. So it means that you can have, let's say, an article that you give to ChatGPT to summarize, and inside you might have 5 materials, except that when you ask about one of the materials, it might give you the properties of the other material. That was also discussed in the article. That might be a problem if you are not familiar with that article and if you don't know the background. And of course, biases, especially if the data sets are imbalanced, if you have lots of endemic words, out of vocabulary words. And also one special phenomenon is words that actually have very diverse meanings. So in one field of science, it might mean one thing. In another, it could mean totally different things. So then you need to actually balance these meanings with some sort of attention mechanisms, like the current attention mechanisms work to some extent. But yeah, we believe that they have to be updated a little bit. So how we are tackling this problem of factuality, and how we believe this could be put on top of this new large language models is, first of all, we want to use also structured knowledge. Like, there is lots of structured knowledge besides the textual knowledge, and we also have the techniques to extract and structurize textual knowledge with same kind of NLP models. And when they are put in a loop, they can actually train each other and learn and be able to augment the final answers. That's like a more longer term process. There are few kind of interesting works done already in the field, and we are also trying to do that on a more practical level. Then it's also about smart large data. So just putting the sheer volume of text that exists on the internet might lead you to these problems that we already discussed. So you need to analyze that training set, and you need to make flags that allow you to measure how balanced it is based on certain criteria. So that's also one of the things that we are doing. And I believe that also the people that built ChatGPT did that to quite some extent, because, yeah, as was the final part of Professor Kutuzov's presentation, there are some safeguards. They try to protect themselves from the same disaster that happened with the Meta Galactica. Google didn't do that, so also end up in the same boat. But these safeguards are actually quite important, and I believe in the future they have to be put in place maybe earlier in the pipeline and not as a post-processing step. But it's still important that they put quite some effort on that. And the final part, which is probably the most kind of longer term thing, is how to change focus. Because right now, all the attention mechanisms and this self-attention is kind of similar for all kind of tokens that the model goes through. And the problem is that facts or numbers or stuff like that, they have to be precise. You cannot just replace it with another number. So they are, how to say, you have to be more focused on them getting them right than some of the words around it that you can generalize, replace. And you also want to have the possibility to paraphrase, because that's what we do. You want the speaker to be abstractive, to be talking more general. So this kind of idea of variable attention or some additional focus mechanism has been entertained in the last 2-3 years. And we believe also that some breakthrough in changing this architecture might be important. Also, there was a discussion about the transformers and that this is the winning architecture so far. You can still do some things, though, in these transformers. You can change the mechanics of the cell inside the transformer. That's also something that we do when we do summarizations, because we can get better results with changing that architecture to some extent. So a few words about how basically we address some of those issues. So for example, structured knowledge. One of the papers that's coming out very soon from Iris.ai is about how to use latent semantic imputation to actually inject knowledge inside the embedding space. So after you have a pre-trained model that has learned the embeddings of particular words, you can actually use external knowledge graph or knowledge base where the knowledge is kind of encoded, and then try to kind of move the tokens inside the space in order to adhere to the new knowledge there. It's a little bit like a process of fine-tuning with those instructions that people from ChatGPT did, but it's kind of more under the hood. So it doesn't go through supervision, but actually goes through directly modeling the mathematics behind the training process. Yeah, so one of the biggest problems, of course, with hallucination and mixed context and stuff like that is actually building the data sets to allow us to measure hallucination and to measure mixed context. So, and making that with human supervision is a very costly and humongous effort. So we're using actually one of our tools that Anita said earlier from the researcher workspace. It's called the extract tool that can build a knowledge graph of entities of interest and facts within a research article or a patent. And we try to use that to match with the graph of knowledge that is built for summarization tasks. So we kind of use summarization as a base for measuring hallucination levels at language models. And yeah, we hope with this new funding to extend the team a little bit more so that we can also publish a little bit more, because that's a little bit effort and time consuming, so that we can also publish these metrics, and hopefully some other people in the field might find that valuable and use it. Then what we believe about creation of structured knowledge is that it will reduce the cost to some extent of fine-tuning or specializing those large language models, because the cost is also very important for startups, for companies in general, for clients, and for business cases in general. And also, right now, a lot of the knowledge that exists is in text and is communicated to the public, but there's a lot of knowledge that is not in textual format. It's gathered in databases, in images, in other formats, what we talked about, multimodal learning. So that's also something that has to be considered going forward in order to incorporate that and make the models more factually correct. When it comes to good quality data, we also believe that the data sets have to be analyzed. So we have tools that actually allow us to analyze the data sets to make sure that different topics of interest are covered, that the different entities are well represented. We do analysis of tokens that actually are skipped during trainings because of their underrepresentation, make sure if we can actually do something to modify that. That allows you to get a perspective on where are the biases in the training set and what to expect going forward. Of course, it has also its own downsides, that in this way you might hinder some of the great discoveries that the model will do going forward, but at least protects you from unwanted biases, especially when you're selling that to a client that works in scientific field, when they want things to be of good quality in order to be able to use it. And so we also believe that good quality data, like once curated and built, it can actually help building the next generation of the models. Then the changing focus, I already said that right now there are several ways in which this could be split. People are thinking about working with the attention mechanisms. Some people do still experimentation with new architectures. It's not that popular field yet, but we believe that maybe there lies the solution to how to focus the attention and how to make it variable over the whole training process. And cost shouldn't be underestimated. Like, if we are able to keep the large language models at, okay, so they're pre-trained, and then the domain adaptation and fine-tuning is cheap, then that's great. But if we have to do extensive fine-tuning and retraining and reinforcement and put human effort, then they become impractical for business cases. And this is kind of our roadmap for how to tackle some of the factuality issues. As I said, we are already working on metrics, so we will be hopefully publishing this year a paper on those metrics. We are curating new data sets of structured data. We are using our extract tool together with our clients to build a large knowledge graph and knowledge bases in different domains in science, currently mostly material science and medical field. We also do this knowledge injection, as I said, like the paper about latent semantic imputation. It's quite interesting, basically adding more or less an additional neural layer on top that uses the knowledge from the large language models, but it's kind of trained in the last cycles of the large language model, so that it allows you to inject this additional knowledge and move a little bit the vectors inside. And then going forward, integrated factual correctness, that's more or less the work regarding the changing of the focus, thinking about different mathematics around the attention mechanism, maybe thinking about something that will be added on top, changing the cell of the transformer, like we are using currently these room cells for summarization. And when we have the new data sets to hopefully train new large language models based on these better quality data sets. that's kind of our pipeline. I can talk a lot about all the details, but unfortunately not enough time here. So yeah, if you have any questions, you can grab me afterwards, and we can discuss that. Then finally, a little bit about the future. So yeah, like plausibility plus factuality essentially should give us the right answer for this question, that actually this particular material is not a good conductor of heat. It's still a metal, but it's a special one. And all of the linguistic features that large language models have today, they are good, so they should be retained, like plausibility, paraphrasing, abstractiveness. But we also need ways to integrate the factual correctness. And we have to use what we have today, like the current large language models, other NLP models, to analyze those data sets that are fed into these machines and make sure that we fight the biases. I think one thing that was said before is really important, that sometimes the biases come from what's the state today, but actually we don't want the future to be that, so we have to control that. And these kind of technologies can actually help us make the change that's necessary faster and not like reinforce it. Yeah, so, and I believe that also after factual correctness, there'll be a lot more work before we go to something close to general artificial intelligence. But there are also some interesting future work for making these models useful for the business, like, for example, training them to know their audience. So recognizing what's the vocabulary of the person on the other side so that they can more or less translate. Let's say the person is not very good in a particular scientific field like material science, so the machine can explain better or more extensively all the terms and use more simplistic English than if it's explaining it to an already domain expert. And this is something about also the engineering concept. Like, large language models were there for 2-3 years, but I also second the opinion that the great engineering work around ChatGPT make it useful and to the public. So the public needs to get a hands on that, because that helps us also spot all the problems, identify new areas of improvement, and help us actually make this available to the businesses as well. And the more businesses are using it, we'll get more feedback and we'll be able to excel that going forward. Yeah, so that's more or less what I had for you today. For these 20 minutes, a bit difficult, but yeah, as I said, if you have any questions or you want to discuss more the technical details of some of our models or the solutions we are doing today or planning to do in the next year or two, yeah, we can chat afterwards. Thank you so much.